Okay, so over here we have a local area network. What is a local area network? A local area network basically means a network inside your home, for example, an office, the whole office building, that could be considered a local area network. And if each different floor, let's say there are 4 floors, and each floor has a different subnet, then it also belongs, it is its own local area network inside the entire local area network, which is the building. Starbucks as well, Starbucks Wi-Fi. This could be considered also a local area network. So the devices that make up a local area network, that could be a firewall, a router, a switch, wireless access points, and hubs. However, hubs, they are no longer being used because we use switches instead. What hubs do is that it only basically allows one device to communicate at a time. And if two devices try to communicate at the same time, their message, they kind of collide with each other, and then they're gonna have to retransmit that message again. So it's like they're fighting to use that network. So we don't use hubs anymore. We use switches instead. So networking devices, you can connect to switches, routers, and firewalls using cable. Some routers or firewalls have wireless, and you can connect to those using wireless. For wireless, obviously we also connect to wireless access points. And for wireless standard, we could use 2.4 gigahertz or 5 gigahertz. 2.4 gigahertz, that will give you not as fast speeds as 5 gigahertz, but 2.4 gigahertz could the distance you could connect to a 2.4 gigahertz wireless access point is further than 5 gigahertz. So 5 gigahertz, if you're close to a 5 gigahertz wireless access point, that's good. But if you're further away, it would be better to use a 2.4 gigahertz connection. Some wireless access points, wireless routers, or wireless firewalls may be able to broadcast both 2.4 gigahertz and 5 gigahertz at the same time, but some older models could only broadcast either 2.4 gigahertz or 5 gigahertz. For cable, we can connect, before we used to connect using a 10 megabit per second cable, then we used 100 megabit per second cable instead. But now what's more common is 1,000 megabits per second, or 1 gigabit cable speeds, just because technology has advanced and this is more widely available, and it's not that much more expensive than 100 megabit per second cable. So a LAN, basically, that's you can consider a LAN as being behind a router, being behind a firewall, and basically if it's not facing the internet, you could consider it a LAN. So a LAN, the most fun fact is the most common subnet for a local area network is 192.168.1.0/24. Most likely that's what you're currently using at your home. Also, for a LAN, if you want to find out what your subnet is, you'd have to take a look at the subnet masks. So a subnet mask, that is a 32-bit value. It could either be ones or zeros. If it's 1, that part of the subnet mask belongs to the network portion of the IP address, and if it's 0, that belongs to the host portion. So for example, if it's a /24, that means 24 bits they belong to the network portion. So if you were to draw out the subnet mask of 192.168.1.0, we have 1, 2, 3, 4, 5, 6, 7, 8 9, 10, 11, 12, 13, 14, 15, 16, dot 17, 18, 19, 20, 21, 22, 23, 24. So that's 24 bits on. If it's 1, it's on. If it's 0, it's off. And we have, since it's 32 bits, 32 minus 24, that's 8. So we have 8 zeros at the end. 1, 2, 3, 4, 5, 6, 7, 8. That's what the subnet mask is going to look like if we're looking at it in binary. If we're looking at it in decimal, we're looking at 255, 255, 255. .0. This would be the subnet mask. If it's in decimal, if it's in binary, this is what it's going to look like. And when it comes to local area networks, they have a topology. They have physical topology and logical topology. A physical topology is how it looks like, how you could see it in person. But the logical topology is how data moves from one computer to another. So if it's a bus, computers all share the same wire. It's a coaxial cable, and this is not being used anymore because, well, it's not as efficient as the star topology, which is what we use right now, the star topology. So the bus, this is not what we use right now because only one device could communicate on the wire at the same time. And if, just like hubs, if two devices try to communicate at the same time, the packets are going to collide with each other, and they're going to have to resend that packet that they wanted to send. And so only one device can talk in the whole network at the same time. As you could see, it would be quite inconvenient. And also, if this cable breaks, that wouldn't be good because then no devices would be able to connect. So we don't use the bus. We also don't use the ring. The ring, how it works is that there are computers connected to one another. Let's say this is a printer. And they're connected like this, like a ring. And I'm gonna skip the YouTube advertisement. And this is playing quite fast. There we go. Cool. So when it is in a ring type topology, they move this way or the other way, but they move in one direction. And only one device could communicate at the same time. And the person with the token could be the one that uses the network at that time. So the token moves from one computer to the next, and the token is like, it works like this. If the token passes on to you and you don't need to transfer data, then the token moves to the next computer, and it asks that computer basically if that computer needs to transfer data. If it doesn't, then it moves on and moves on and moves on and moves on and moves on until it reaches the computer that needs to transfer data. Then that computer will then use that token to transfer its data to, let's say, the printer over here. And then the printer will, continue passing along the token until its job is done. It needed to communicate what it needed to, it sent the data that it needed to the right server, and that's all it needed. So this one stops using the token, and then the token continues moving, so on and so forth. And if one connection is broken, let's say that connection is broken, the whole network doesn't work. So it's not quite efficient. So we don't use the ring topology anymore. What we do use is the star. And we use the star through, let's say, a switch. So here's a computer. Here's a TV. Here's another computer. here's the router. Kind of like a star. And here's another computer. So the star topology basically, for a switch, if this device wants to send data to the internet, and the router connects these devices to the internet, it just sends that data to the switch. And then from the switch, it sends it to the router, and then, which is its default gateway, and then it sends it to the internet. This one works because even if this cable was damaged, this device could still communicate with the switch, and then it could still communicate with the router. So it works. It's having one connection in this whole topology failing doesn't affect the other devices. That's why we use the star topology right now. So that's what a local area network is. It's a group of devices, of computers that reside behind a firewall or a router, and it's in one geographical location. Also, in one geographical location, there could be multiple local area networks depending on their subnet. So all devices that belong in one subnet belong in one network. That's a local area network. Even if you're in the same building, if you belong in a different subnet, you belong into a different local area network. But you could also say that because they are in the same location, the whole building is its own local area network. That's what a LAN is.